Hello everyone, welcome back to this lesson, and we shall be doing more examples on undefined events, and we shall start right away. So example 3 reads, events A and B are such that probability of A is equal to 0.4, probability of A intersection B is equal to 0.1, and probability of A union B is equal to 0.9. And in part A they want us to find the probability of B. So in such a scenario, we have to look at what we are given and check whether it can help us get what the question wants us to get. For example, in a question I'm given the probability of the union, and I can actually use that because I'm given probability of the union, the intersection, and probability of set A. But I know that my probability of A union B is actually equal to the probability of A plus probability of B minus probability of A intersection B. So if I substitute, I'll have 0.9 being equal to probability of A, which is 0.4, plus probability of B, which I'm looking for, minus probability of A intersection B, which is 0.1. So when I collect like terms, I'll end up with probability of B being equal to 0.6 as my answer. Then part B wanted me to find probability of A complement intersection B, which is the same as probability of B only. So probability of B only or A complement intersection B is actually equal to probability of set B minus the intersection. So I'll have my probability of B as 0.6 minus the intersection, which is 0.1, and I'll end up with 0.5 as my probability of A complement intersection B. Then part C wanted me to find the probability of A only or probability of A intersection B complement. So probability of A only is the same as probability of A minus probability of A intersection B. So I'll have 0.4 minus 0.1, which will give me 0.3 as my probability of A intersection B complement. Then part D wanted me to find probability of A union B complement. So to get probability of A union B complement, don't forget what I told you. I told you that if I have probability of A union B, it's the same as probability of A plus probability of B minus probability of A intersection B. But the question wanted A union B complement. So what I will do is that I will look for B, and wherever B appears, I will keep fixing a complement. So I'll put a complement there, a complement here, and a complement here. So by substituting, I'll have probability of A, which was given as 0.4, plus probability of B, which is actually 1 minus probability of B, which is 0.6, minus probability of A intersection B complement, which was given as 0.3. And I'll actually end up having 0.5 as my probability of A union B, but complement. That's our third example under undefined events. Next example says events A and B are such that probability of B only is equal to 3x, probability of A only is equal to 2x, and probability of A complement intersection B complement is equal to x. And probability of B is equal to 4 out of 7. We are required to use a Venn diagram to find these values. So I can start by extracting important information. I've been given probability of A complement intersection B as 3x, probability of A intersection B but complement is equal to 2x, probability of A complement intersection B complement. So I know that probability is the same as probability of A union B but complement, and it's equal to x, and probability of B is equal to 4 out of 7. And I want me to use a Venn diagram to find those given values. So I'll proceed to draw my Venn diagram and fill in the information I've been given. Okay, so I can call this probability of A and this probability of B. So I've been given probability of B only as 3x, this over here. Then probability of A only have been given as 2x, probability of the intersection is not given, so I can just leave it as probability of A intersection B. But I've been given the probability of A union B but complement as X, so I can put it there and proceed to solve for X. Okay, so in the question they have told us that the probability of B is equal to 4 out of 7. So we should have that at the back of our minds. But then we also know that the probability of the union can be got from, so probability of the union A union B can actually be got from, okay, I know that probability of B is equal to 4 out of 7, so that entire part is equal to 4 out of 7. Yes, so that probability can be got from probability of B plus, I'm using B because I already have it as 4 out of 7. I don't want to stress myself with these values, plus the probability of A only, which is probability of A intersection B complement, plus the probability of what I have outside. Okay, that's it, because if I added outside, I'd have gone outside the union. A union B is just these two sets, what I have here and there, everything inside added, but not anything outside those two sets. So I hope that's clear. But in the question, I have not been given the probability of A union B. What I have is A union B but complement. So I'll have to manipulate this A union B and introduce A union B but complement. So I'd have 1 minus probability of A union B but complement is equal to probability of B plus probability of A intersection B but complement. So I can make my substitutions at this step. So I'll have 1 minus probability of A union B but complement is X, being equal to probability of B, which was 4 out of 7, plus probability of A only, which is 2x, this value over here. So when I collect like terms, I'll actually end up with, when the x crosses, I'll end up with 3x being equal to 1 minus 4 out of 7. And when everything simplifies, I'll end up with my x being equal to 1 out of 7. So I finished solving for x. Part B wants me to find probability of A intersection B. So probability of A intersection B is this region over here. So I know that this entire set is 4 out of 7. And then I also know the value of x. So it means that I can easily get the value of probability of A intersection B. Since I know that probability of A intersection B plus probability of B only, which is the same as A complement intersection B, is actually equal to probability of B. So if I make probability of A intersection B the subject, I'll have probability of A intersection B being equal to probability of B minus probability of A complement intersection B. But my probability of B was given as 4 out of 7, and my probability of A complement intersection B is this value over here, which is 3x. So 4 out of 7 minus 3x, but my x is 1 out of 7, so it's the same as 4 out of 7 minus 3 out of 7, and I will actually end up with my probability of A intersection B as 1 out of 7. Yes, so that will be our last example under undefined events. When we meet in the next lesson, we shall look at more interesting events, and we shall see how we can tackle such examples or such scenarios. But maybe to recap, for undefined events, we don't have any condition on the intersection. So we shall see what I mean by no condition when you look at the other types of events, like the mutually exclusive events where the intersection is equal to 0, or the independent events where we shall see how we treat the intersection of events. Thank you very much for attending our lesson. I look forward to having you in our next session. Goodbye.